Hey guys, it is December 6th, 2021. You should be having your opening task paper out. If you forgot to get it, go get it now up on the front. It should be a new one. Make sure you have something to write with. You're sitting in your assigned seats. The sub should be taking roll and you should be working on your opening task. So let's go ahead and get started on that. Let's see if I can get it up here. It is week 15, so go ahead and write at the very tippy top, week 15. If you are period 2 or period 4, go ahead and write that at the top. And today in your Monday section, you're going to write 2.3, ready, set, go. All right, so today your homework when you leave is going to be 2.3, ready, set, go. Okay. So if you are working on your opening task, it is just a math joke that Mr. Churchill thought was pretty funny. He says, why can't your nose grow to 12 inches long? Why can't your nose grow to 12 inches long? Anybody think they know the answer? You're right, because then it would become a foot. Haha, if you see Mr. Churchill, tell him he needs to work on his math jokes. All right, here we go. Let's go ahead and get started. Let's see if I can find where I put our stuff. Right here. Okay, here we go. We should be 2.3 is all the way down here. 2.5, oops, went too far. Man almighty. I can't wait to get back, you guys. Okay, 2.3 starts on page 19, so you should be on page 19. And it is going to be talking about, it says compare rates of change. Rates of change. And the best way to be thinking about this rates of change is the bigger the fraction, the bigger the rate of change. So if I'm thinking something like this, if I have 1/3 versus 2/3, the rate of change, 2/3 obviously is bigger than 1/3, the bigger the fraction. But if I have 3/2 or 4/3, 4/3, then it becomes a little trickier and we have to find a common denominator. We have to break it into equal size pieces in order for them to find out the rate of change, which one is bigger. Okay, so I want you to just be thinking, we're thinking about rates of change, and in some of them are linear and some of them are exponential. And so some of them might have different rates of change at different areas. Okay, so here's kind of how it looks. It says identify whether A or B has a greater rate of change. Well, from a table, we see the rate of change happening from here to here, and we write it as a fraction. So this one's changing from 48 to 43. It's changing +5. From -43 to 38, +5, +5. So this is a 5 for every one. And remember, we write our rate of change as, from a table, the change of the y goes in the numerator and the change in the x goes in the denominator. So that's important because 1/5 is definitely not as big as 5 for every one. All right, so the rate of change here is my y in the numerator, my x in the denominator. So this one is changing 5 for every one. All right. In a graph, if you remember, we have to go and we have to find those bullets, those bullseyes, and we have to find where it crosses perfectly. So as I'm looking, I notice it crosses right here perfectly. And as I'm going up, remember it has to cross all three perfectly. It looks like it crosses right here perfectly. And as I'm looking at a graph, remember in graphs we make a slope triangle. We make a slope triangle. So I'm going to go ahead and I'm going to say, all right, it's going to say how far does it go from here to here and how far from here to here. So as I count 1, 2, 3, 4, 5, 6 on my y, and it changes 1 on my x. And remember, it's my change in my y, that triangle change in my y goes in the numerator, and change in my x goes in the denominator. So this one right here changes 5 for everyone. This one changed 6 for everyone. So when I'm looking at it, it says which one has a greater rate of change, A or B? In this case, it's going to be B. 6 for everyone is a greater rate of change than 5 for everyone. Okay, let's go ahead and let's try the next one. A and B. All right, so we're going to take a look. We're going to find those perfect bullseyes, and we're going to find those perfect bullseyes, and then we're going to turn it into, so there's one right there. Looks like there's one right there. There's one right there. And there's one right there. So when in doubt, make a table. When in doubt, make a table. So when we make a table, we have, I'll put it right here and right here. My x goes on this side. The y values go over here. And this is going to be 0, 1. Oops, let's do that right here. 0, 1. And the next one is 1, 2. And the next one is 2, 4. The next one looks like it's 4, 1, 2, 3, 4, 5, 6, 7, 8. 4 and 8. So now that we have this table and it looks like it's a curved graph, we know it's changing with multiplication. Looks like it's changing by a rate of times 2. Times 2 is my rate of change. Okay. Now let's go ahead and let's look at the next one. I've got a perfect bullseye right here. Looks like I have a perfect bullseye right here. And it looks like my next perfect bullseye is off the charts. But I'm going to go ahead and just make a table just for fun to see if it's curved, so I know it's going to be changing with multiplication. I have an x. I have a y. My first x is 0 and 1. And my next one is 1, 1, 2, 1, 2, 3, 4, 5. 1 and 5. So if it's changing with multiplication, how do I get from here to here? Well, it's going to be a times 5. All right. So B again is the winner. You're going to go ahead and you are going to work through 3. You're going to compare A and B, A and B, A and B. This one right here, remember, when in doubt, turn it into a table. So I would say when x is 0, what happens when I have anything to the 0 power is 1, and 1 times 2 is 2. And then I'm going to plug in 1. 1, 5 is 5 times 2 is 10. Then I'm going to plug in a 2, right? 2 5s. 5 times 5 is 25. 25 times 2 is 50. And so on. Okay, so when in doubt, when I'm solving for y, I'm just going to plug 0 in for my exponent here. Then I'm going to plug 1 in for my exponent, and then 2 in for my exponent, and see what's happening, and then compare it to over here. If there's stories, I strongly suggest you making a table or you're making sense of it. Tables usually are the best way to go. You could also try to turn them into a graph if you want. All right, down to your set. It says, based on each of the given representations of a function, determine if it is linear, exponential, or neither. All right. So you have 6, 7, 8, 9, 10, and 11. Let's see. The population of a town is decreasing at a rate of 1.5% per year. Okay. So when you see percents, You should have flashing lights. We know that that is exponential. It's going to be decreasing at a rate. Okay, so this one is definitely exponential. Okay, be going through these here. All right, for your go, for each of the geometric sequences, ding, 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 that means from here to here, it's changing with multiplication. And from here to here, multiplication. And from here to here, multiplication. Find the missing terms. All right, so you need to be thinking, what can I have to multiply 2 by? 1, 2, 3, 4 times to get up to 162. Multiplication or division, 12, 13, and 14. All right, we will be correcting these tomorrow at the beginning of class, so get them done and then compare them with your seat partners. When you are done with that, you are going to go to the next assignment in Google Classroom. All right, so get this one done for sure. This one is due tomorrow, the beginning of class, page 19 and 20, and then go back into Google Classroom and do your next assignment titled Monday. All right, guys, miss you. I'll see you in a couple days.